Hi girls. Today we are going to review chapter 8. Chapter 8 is very easy and was not short, but it was easy and most the idea around each other. So in this chapter, we discussed about polynomial. So once we discussed about polynomial, we learned how to classify them and how to find the degree for monomial. So let's get started. First of all, the meaning of polynomial, it's many terms, which means many terms that I have like this, between them addition or subtraction. So first of all, let me start with the first lesson, which was talking about classifying the polynomial. So let's do that. So the first one here, I will try to find the degree of each monomial. So if I have one term, I will say monomial. If I have two terms, I will gonna say it's binomial. If I have three terms, I will say trinomial. This is the idea. So for the first one, the degree is 3. The degree here is 2. The degree is 0, which is the degree. I will take the power of my variables. Here the degree is 12. The degree here is 7. The degree here is, add them all, 4 plus 3 plus 2, it will be 9. So the degree is 9. So that's how I find the degree of monomial, which is only one term. Then we discussed about standard form. How can we write the standard form? We can write the standard form by listing all the monomials, each term from according to the degree from greatest to least. Like here, the degree of this monomial 1. The degree of this one is 2. The degree is 0. So how can I order them, or how can I write the standard form? I will say that is x to the power 2 plus 4x minus 1. Here is same idea. I will write first 3n to the power 2 to the power 3 plus 2n to the power 2. Here we can say -4, it's already in the standard form. This is already in the standard form. Okay, so we did not finish, we did not answer all things in this question. We just answered the first part from the question. Then name each polynomial based on degree and the number of terms. So I will gonna write based on degree first, then the number of the terms in the second part. So since this one, it has the degree 2, the greatest degree for monomial, it's 2. That means I will gonna say it's a quadratic. So that is, and I have 3 terms, so it's a quadratic trinomial. So that is a quadratic trinomial. I'll try to organize my handwriting as much as I can. Because I really worried if I don't write, you don't write them. Trinomial. For this one, here, cubic. So then you have 2 terms. So according to the degree, the greatest one is a cube. So it's a cubic binomial. So that is a cubic binomial. So I did with you only I will do with you also this one, because I want you notice that this one and this one, the same power, the same degree, so I should simplify them. So that will be negative W plus 3 plus 8W to the power 3. So after that, I'm going to reorder them. So that is 8W to the power 3 minus W plus 3. Then you will classify it. Once I classify it, the greatest power is 3, so it's a cubic, and I have 3 terms, so it's a cubic trinomial. So here we have a cubic trinomial. Then we have the degree here is 0. This is already in the standard form. So it's already in the standard form. It is constant monomial because you have just number. So according to the degree, we will say it is constant. Then we will say it is monomial. Here we can classify it. This is already in the standard form. We can say, I just want to tell you that or show you that this is linear. If you have the power or the degree is 1, you will say it's linear monomial. So it's monomial. This one, 4th degree binomial. So that is 4th degree binomial. I'm not going to write. So here we are going to simplify. Simplify, which means if I look at it like this, I will just and write it each in a standard form, which means I will add only like terms, because if I have addition, remember, these two parentheses does not stuck. These are not stuck. So between them addition or multiplication, that means I have to focus on that. So let me solve with you the some of them. I'm not going to solve all of them. If you look at this term, exactly the same as this term, but keep in your mind, if you have negative, you need to distribute this negative for all of them. So before I do anything, let me distribute this negative for all of them, but I'm not going to write this again. So if I distribute it, that will be negative 3. That will be plus, because negative will be plus. That will be minus. That will be plus. Let me work on that now. So since the first two, this one and this one, exactly the same term, so I'm going to add them or subtract them according to my sign. So 5 minus 3, it will be 2x to the power 3. Next, let me show you if I have this term, this is corresponding to this term. These are like terms. So that is 3x to the power 2. So 3 plus 1. There is nothing, that means it's a 1. Don't forget that I distributed this negative and this negative. So that is 3 plus 1. It's a plus 4. X to the power 2. And you have also this term exactly the same as this one. So negative 7, negative 4 will be negative 11. So negative 11x to the power 1. Finally, we have the numbers 10 and 1. It will be plus 11. So this is the idea. Just all of them exactly the same. But I'm going to solve with you another one. So let me solve with you also this one. I just want you to notice that this one with this one. So because they are like terms, same variable, same power. So negative 4 and here is addition. So no problem, nothing will change inside. Negative 4 and positive 8. So I will have 4w to the power 2. Then let me change the color. So we have 9w and 5w, they are like terms, so both of them positive, so it will be plus 14, and I'm writing them immediately in the standard form because they want me from the standard write in standard form, so that is w. Finally, we have just the number that we have, which is 10 and 7, so which is plus 17. I'm not wasting the time just doing all the exercises exactly the same idea. Just keep in your mind, if you have negative, distribute your negative as I did here. You can just rewrite it if you feel that this is confusing you. If you want also to do like the horizontal way that we did, or the vertical way, this is the horizontal, sorry. If you would like to use the vertical way that we did in the class or in the beginning, once we start doing that, let's do 16 like this. I'm going to also to distribute my negative sign, that will be plus, that will be plus. So what will I gonna do? I will say 8t to the power 2 plus t plus 10. And then under this 8t, I will write the like term for this one. So it will be negative 9t to the power 2, then plus 9t plus 1. Now, since you already distributed the negative, so just add them. So that is will be negative t squared plus 10t plus 11. That's for adding and subtracting polynomial or polynomials, yes. Now here I would like to show you, and I want you focus on very small and important thing. If I'm asking you to find the parameter, that is mean I need from you to take these two sides and use them to find the parameter of rectangle. What is the parameter of rectangle? 2 length time plus 2 times width, right? So you need to substitute these two in L and W. While if I'm asking you to find the area, you need to multiply these two binomials. Let's do it according to what we need in the question as a parameter. So 2 times 4t minus 1 plus 2 times 5t plus 9. So distribute your 2. So once you distribute your 2, you will have 8t minus 2. Don't forget to distribute it for both terms, please. So distribute again here. So that is will be plus 10t plus 9, it's 18. Now you can just add like terms together. So these will be 18t minus, or sorry, it will be plus because minus 2 and 18, it will be plus 16. So that is for this part. Now find an expression for the parameter for each figure. As I did, rectangle, exactly same thing that I did here. That is similar idea. I'm going to do with you for the triangle, just to show you if I want to do it. So I have, these are the sides for my triangle. So just add them all together. So 2t squared, the parameter will gives you 2t squared plus 4t minus 3 plus, take the last one, 10 minus 2t. I did not do anything. I just added all these together. So just once you add them, you need to add the like terms. The first one, 2t, I cannot add it with anything to the power 2 because the power 2. Plus 4t and minus 2t, I can subtract them. So that is 2t. Then I have Negative 3 and 10, I can say that is a plus 7. Ramos, you know the Ramos, it's this one, which is something look like it has 4 sides. You will take just only this one, add it 2 times. You can just multiply it by 2 and just take this one, same thing, and add it 2 times, or you can multiply by 2. So that's for this part. Let me move to the next part, which is lesson A2, simplifying. If you have something like that, simplifying, you just need to distribute your monomial onto the polynomial that you have. Let's do that. So I'm going to do with you some simple and easy exercises. So just distribute this one for these two. So 4 times 8, it is 4 times 8, you are going to say it is 32. Miss, it is 32. M times M, M times M, I'm going to add the powers, which is M to the power 2, minus 5 times 8, which is 40. And miss, I have M outside, so 40M. So it is like you will take the power that you have here, you will add it with the power that you have inside. Remember, it is multiplications once you distribute. Let's do one more. 2m to the power, just add their power. So that is 2m to the power 5 plus 2m to the power 3 minus 4m to the power 2. That's it. I'm going to do one more with you to make sure that you are okay with this idea. So I will do also with you this one and this one, so at least we can have, so 5r to the power 4, 5r to the power 4, plus 5 times 4, 20, r to the power 3, minus 10 r to the power 2. For this one, I will distribute, and I should notice that I have negative here. So that will be negative x minus x to the power 2 minus x to the power 3. It's like you adding 1 to your power if you are multiplying by a power here 1. Now, the next part, finding the greatest common factor for the polynomial. I started with you basically by using and analyzing each term, but now I think now you are improving and you don't need me to analyze for you each term and writing this way like this, 3 times y times y and times y. That is the basic idea, times y, and then for this one you will say 3 times 3 times y, and then you will take the common between them, which is this one and this one and this one here. I don't think that you need to do this step now. If you feel that you are not confident, do it. But if you feel that you are confident, you can directly, like these numbers, very easy. I can see in the numbers there is a 3. In the variables, I can take the smallest power, which is y to the power 2. Okay, what is the opposite? It's like the opposite direction of this one. So this is the greatest common factor. So that is my greatest common factor for this step. If I ask you to factor and factor, so find the greatest common factor and factor. So that is equals to 3y to the power 2. And then open your parentheses. What is the remaining here? You already took 3. So, and y2. What is the remaining inside? Y to the power 2. You took 3 and y to the power 2. What is the remaining? Minus 3. If you want to check your answer, multiply again to find your answer. Let's see this one. So here, I don't have numbers. All of them 1, so no common, the common 1, so no problem with 1. Now I will look all the variables. I will look at the smallest power. The smallest power is this one. Okay, let me take it outside. T to the power 2. That is my greatest common factor. Now, what is the remaining inside? T to the power 4. I will minus from this power 2 because I already took 2 outside, plus T to the power 4 plus, sorry, minus, it is minus so that is, let me erase what I did here and then use the same thing, minus T to the power 3. From this one I took 2. If nothing, you took all of it, put 1. Don't leave nothing, no, put 1. So that's for this part. Let me do with you one more and then I will move to other thing. So here, what is the common between them? I will realize directly between them all 5. For my variables, the smallest powers are to the power 1. I will take it. Okay, if I took all this term, the remaining is 1. Plus, here, 4 r to the power, I took 1, so it will be 2. Plus 3r. That's for this part. So I solved with you 3 questions, and we will repeat this idea many times. Look at this one now. If you have a rectangular roof has length of 13g and width is this one. So write an expression for the area of the roof. So that means I need you to find the area for the roof. You just need to multiply them. Area equals length times width. So which is the opposite of the thing that given up, which is the parameter. Here they are asking me to find the area. So just multiply them. 13g times 4g plus 7. So just distribute. So that is 13 times 4, it will be 26, 26 times 2, it will be 52. So that is 52 g to the power 2. And then you have 7 times 13 will give you 91. So that is plus 91 g. So here you have, if you have a cylinder, I will find the volume for a cylinder with base area. So they gave me times the height. Again, what is the volume? What is the area of the volume? What is the, sorry, the volume? What is the volume of cylinder? It is the area of base times height. So the area of base times the height. That's the volume of cylinder. So they are giving me the area of the base, which is 3w 2 plus 5 times height, which is 4w. Just multiply them by using exactly the same way. In the next part, we have to simplify each given product. We learned in this part some special rule and the other regular and easy rule, which is by using distributing. Remember, we finished here multiplying only one monomial by polynomial, which is including many terms. I want you to notice here that I'm multiplying here polynomial by monomial or the opposite and so on. So the basic idea, even if you don't know any rule, for example, let's say you forgot everything. So the basic idea is just multiply this one by all things that you have here, these two, and same thing with this one, multiply it by all things that you have it here. Remember here they are stuck, that means multiplication. So let's multiply them. 5c times minus 5, minus c. It will be minus 5 c to the power 2. Then 5c times 2, it will be plus 10c. 3 times minus c, it will be minus 3c. 3 times 2 plus 6. Now just simplify the things that you can simplify them, which is this part, because 10c and minus 3c, which is 7c plus 6, and that is minus 5c to the power 2. Keep in your mind all this for this question. Let me solve with you also two more questions. I would like to tell you, if you feel that this my way is just confusing you a little bit, let me show you what do I do. What will I gonna do? So that is 2 times, I can write 2n times all this parentheses, which is 2n plus 4. If you feel what I'm doing by using this way is confusing you, this one with this one, this one with this one, again, this one with this one times this one. So you can do like this way. That is minus, should be minus. So minus 3, which is this term, times 2n plus 4. Then just distribute them. That is will be 4n squared plus 2 times 4, 8n minus 3 times 2, 6n minus 3 times 4, which is 12. Add the like terms, which is these are like terms. Just add them. That is will be 4n to the power 2 plus this is will be 2h minus 12. That's the idea. The idea is very simple. What about if I have something like this? I mean, in other words, I can say that is 3x plus 1 times itself. 3x plus 1. So, this one, we learned a rule. If you don't remember the rule, I will remind you now. A plus B, all this to the power 2, that is equals to first term squared, last term squared, 2 times first term times the second, 2 times first times second. So, let's do it directly here, which is easier than having 4 terms like this. First term squared, so just take it 3x, all this, remember. If you don't feel that this makes sense for you, put parentheses and put them plus 2 times first times second term, 2 times 3, it's 6x, times 1, it will be 6x, plus the last squared, and you are done. You did not finish yet. You must simplify it more. Be careful. So that is, you should write here, you should distribute your power for this one and then say that is 9x to the power 2. So you must say that is 9x to the power 2. Since there is no space, so I'm going to, so that is 9x to the power 2. Now, I told you also about the difference between two squares. If you have exactly the same two terms, but the only difference between them is the sign that in the middle. So it is not like this one exactly the same sign, the same term. Here you have them opposite. We learned a rule tells us that these are difference between two perfect square. We are going to say A minus B and A plus B, and that's what we have here. We are going to use this rule exactly in the opposite direction. So I can say directly that is A squared minus 4 squared. So what is 4 squared? I will tell you A squared minus 16. I'm done. So that's the idea for simplifying each product. So you can multiply them step by step as I did here. If you don't know any rule from these, Or because not always you can multiply them by using this rule or by using this special case. The basic idea is multiplying the regularly by term, except if you have two polynomials, you are multiply them by themselves. So again, here you have a rectangle with dimensions, this one and this one. I'm not wasting the time, write the expression to show you the area. So the area, again, just take this one times this one, multiply them to get the result. Please solve it and add it in your notebook. Write an expression for the product of two consecutive odd integer, n and n plus 1. So just you need again to take this one and n plus 1, multiply them together, the product of two consecutive odd integer terms, which is this one and this one, multiply them to get the result. So here, if we have a circular pool has radius 5p minus 3 meter, right? I will solve this one. You know the area because that is important, this kind of a question important. So that is A equal pi r squared. So if you have something like this, you need to change this one. Be careful. This r is this. So just say pi and then open your parentheses 5p minus 3 squared. So this squared, it's for all of them. We just said before a few minutes what is the rule for that. So that's is the first term squared. Just you can, it's like you can sing it. The first term squared, the last term squared, 2 times the first times second. 2 times first, 2 times 5, it's 10. 10 times 3, which is 30. So minus 30 p plus. So keep in your mind that is squared here. I forgot to write the square. You can keep it the pi outside, or you can distribute your pi and say 25 pi p squared minus 30 pi p plus 9 pi. So that's the idea. So as I told you, I'm not solving all the exercises because most of them exactly the same idea. Here I have again a rectangle with the base with side length is this one and this one. So write an expression for the area of the floor of the building. Exactly same thing. You know what is the area of the floor, which is as a rectangle, length by width. So just take your polynomial that you have, just multiply them. So for a question 62, I will fix these squares. What's going on with these squares? So for 62, suppose you play a game with two number cubes. Let A represent the rolling a number less than 4, and B represent rolling a number greater than 4. The probability of A is, I'm not giving you the probability of A is 1/2 here. If you would like to try it, I'm not going to solve it with you because this is a probability and our lesson or our chapter does not talk about the probability. So I'm not solving with you something with the probability. So 1/3. Anyway, it's easy. Here they are asking you to find 1/2 A plus 1/3 B, all this to power 2. Just find this one. How can you find it? You will substitute. What is A? It is this one, 1/2. What is B? It is this one. You will just, sorry, you will take this one, just 1/2 A plus 1/3 B. You will use your rule, which is the first term squared, the last term squared, and so on. Just the story that I did before. So here we have in this question, I will move, so this question is not, I don't need it. So suppose there are two squares with side length, this one and this one. So I have two squares. The first square is, let's say, 4x minus 3. The second one is 2x plus 4. Write an expression for the area of each square. Find the area of each square if x equals 6 centimeter. So first thing first, I will find the area for square 1. So the area for the square, it is one side squared. So the area for this square, I will say it is equals to 4x minus 3. All this to the power 2. So the first term squared, use the rule. So which is 16x, then the last term is 9, then minus from here 2 times first times second. So 2 times first, 8, 8 times 3, 24x, 24x plus, and then here it will be 2 for the first term squared. So that's for the first square. The second square will be the area is equals to, again, I will take its side and then I will raise it to power 2. So that is x, 2x plus 4. All this to the power 2. So that is equals to just the first term squared, 4x squared, the last is squared, which is 16, 2 times first times second, 2 times first 4, 4 times 4, it's 16x plus. Now they are telling you next, if you have when x equals to 6, what is the area? Just substitute. You can substitute from here. So if x equals 6, so you can say just 4 times 6, it's a 24. 24 minus 3, 24 minus 3, which is a 21 to the power 2. Just by your calculator do it and then give your answer. So 4 so that is raised to power 2, which is 400, which is equal 441. Similarly, for this one, exactly the same idea. If you have it, if you have 6, if the x equals to 6, once you substitute, you can just get to 5.6 centimeters squared. You can substitute here or you can substitute here. It's up to you. So for lesson 8.5 to 8.7, we are going to factor the forms x to the power 2 plus bx plus c. So you can just, or you have ax plus bx plus c. And we discussed about special case that we did if we have a squared plus 2ab plus c. So we also discussed about the difference between 2 squared minus b squared. This was the special case in these 3 lessons. So in these 3 lessons, yes. 5, 6, 7. In these 3 lessons, we were discussing about how to factor these 3 forms. Let's start. So first of all, if I cannot figure out anything, I will just say that, okay, A times C, the basic or the general thing for this form, for these 3 forms, I mean, it's this part. So I will say what is AC, which means the coefficient for x squared and the constant that I have. It's a 3. All right, 3. I will think about 2 numbers. Once I multiply them, I will get a 3. Once I add them, I will get the number that I have in the middle with the x, coefficient with the x, equals -4. So that's so easy to find. You can just say 3 and 1, both of them negative. If you have both of them negative, in multiplication will give you 3, but in addition or subtraction will give you -4. Great. So let me write my working here. So x to the power 2 minus, I can directly, write that is x. If I don't have a coefficient here, directly write minus 3 x minus 4. So similarly with the others, let me just do with you one more with the other form, which is this one. So 2 times -3, it will be -6. Think about two numbers. Once you multiply them, you will get -6. Once you add them, you will get the value that you have in the middle, which is 1. So what are these two numbers? Definitely 3 and 2. One from them should be negative. Because I have positive, so I will keep this one positive. That is 2 negative. 3 times -2 will give me -6. Also, 3 plus -2 will give me 1. That's what I need. Now I will rewrite this one. Since I have a coefficient here, I cannot directly write like this. Be careful. Here I could directly, once I find these two numbers, خلاص, I'm done. Just x, the variable that I have, minus the number or plus, depend on the sign that you got. And then in the another parenthesis, don't forget the parenthesis also. Please don't forget the parenthesis. So here you can say that is 2n squared. I will keep minus 2n plus 3 and drop this 3 minus 3. Now I will take the common factor between these two, which is 2n, and then inside the remaining is n minus 1. Here is same thing, I can take a 3, and then the remaining inside n minus 1. So these are same, just take it outside, n minus 1, 2n plus 3. So I'm done. Like that, I could factor it. Now let me show you 80. That is one from the special case that I learned, which is a to the power 2 minus b to the power 2. I can rewrite this one into 3c, all this to the power 2. Now I know 169, it's 13 to the power 2. So directly I can say, okay, that is 3c minus 13, 3c, write it beside it, but I don't have a space, plus 13. So one set's positive and one set's negative. So that's the basic idea. Here, this one also, I would like to show you that this is also one from the special cases. So that is 2. 2g, all this to power 2, plus 2g, 2 times 2 times 2g, plus 1, isn't it? You can just directly say, okay, now that means that is 2g according to the rule that I gave you, 2g plus, I have this 2, this is, I can represent it by a, and this one is same thing. So that is 2g plus 1, all this to the power 2 according to the rule that I wrote it for you here. This one, which is what I wrote it here up. This rule. So the others, exactly same idea. I will post for you the answers. Please have a look at them, try some of them. If you face difficulty, please ask me in the office hour. These also exactly same idea. So I'm not going to work with them. So write an expression for the radius of a circular flower garden with an area, which means they want you factor this one. Since you know that the area is what is equals to for the circular r to the power 2, which means I need to factor out the pi. I will take pi outside. Once I take pi outside, the remaining inside m to the power 2 plus 14 m plus 49. You know that you can rewrite this one according to the rule that I just did. Keep pi outside. If you keep pi outside, you will have m to the power 2. You can separate this one. You can say that is 2m times 7 plus 7 to the power 2, isn't it? That's exactly the same rule. I can use it one from the special case that I did. So that is pi times a, it's m. What is b? It's 7. Why all this to the power 2? So what is your radius? So the radius for this flower garden is m plus 7. So that's the idea for this part. So all these, use factoring to find expression for the possible dimension of each figure. I don't want you get boring because all of them exactly the same idea. Exactly the same idea. You will try to factor them. If you have a coefficient here, or if you have common in all of them, you will take it outside first, then you will use the idea of AC, and then you will think about two numbers. Once you multiply them, you will get the number that you will get it from AC. Then once you add them, you will get the number that you have in the middle, which is this one here. So I'm not wasting your time again doing it because the time is running fast and I don't want you feel boring watching my video. So here finally, if we want to factor anything with power for lesson 8 with power, or I mean terms more than 3 terms. If I have more than 3 terms and I can say the powers more than 2, I would like to see first. Step 1. See if you have common factor in all of them. If you don't have common factor in all of them, try to group each two together. Like this one, let me do with you 96. I will group the first two together. Once I group the first two together, I can find between them 3. Y to the power 2. What is the remaining inside? The remaining inside, y minus 3. All right, here, what is the common between them? The common between them, it's only the negative. So I will take my negative sign, which is -1, and then I will keep y plus 3. Now, great, I have this one exactly the same as this one. I will take it out, y plus 3, and then I will write the remaining thing that I have, which is 3y to the power 2 minus 1. So that's the idea. I'm going to solve with you also one more question. So again, do I have common between all of them? No, I don't have. So I will group each two terms together. I will group these two, which is the common factor between them, 2n to the power 2. What is the remaining inside? The remaining inside n. And here, if I took 2 here, the remaining 5 only. I already took the 2. Plus, here, the common between them 3. Inside n plus 5. Why I'm saying that? If I multiply them, I will get this again. This one exactly the same as this one. Just pull it out. n plus 3, n plus 5, 2n squared plus 3. That's the idea. The idea is really easy and simple. For factoring and finding expressions for the possible dimension, if you have rectangle again, the only thing that they updated here, we have more than one terms. So all of them exactly same idea. Let me do 107 because there is a space here. So here I have, do I have common factor between all of them? No, I don't, because no, I cannot. So I'm going to group each two together. So here I have to say 3n to the power 2 again, it's common between them. That will be 2n minus the remaining is 3. You have to focus on this one. If you take negative sign here, this is one you deal with it. It is like negative, negative. Please be careful if you take negative sign from this number. So you can take from this number common factor between them 4. So the remaining is 2n minus 3. Okay, because once you multiply, you will get these two terms as it is. So take this outside, 2n minus 3 times 3n to the power 2 minus 4, and like that you are done. So basically this chapter is very easy and important in the same time. Make sure that you know what to do if I'm giving you something like this. For example, if I'm giving you this is a circle and then I'm asking you to find this shaded part. Keep in your mind you are going to find the area for the circle, then you will minus it from it the area of the square. Please be careful if I'm giving you something like this. And I did with you several and many exercises related to this part. Good luck, girls. Bye. You will find the this sheet in the files if you want to print it. Good luck. Bye.